Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the leftover concepts of energy. Law of conservation of energy. Energy cannot be created nor destroyed, but it can be converted into other forms of energies. Like sum of initial energies is equal to sum of final energies. EI means sum of initial energies and EF means sum of final energies. Some important cases. Number one, a block moves horizontally by the applied force F. So according to law of conservation of energy, work done by applied force is the initial energy, and this will be distributed into two types of energies, change in kinetic and work done by friction. For example, work done by F is 1000 joules, change in kinetic is 700, and work done by friction is 300. Therefore, 1000 is equal to 1000, which is according to law of conservation of energy. Case 2. A block moves up the slope by applied force F. So according to law of conservation of energy, work done by F is the initial energy, and this will be distributed into three types of energies: change in kinetic, work done by friction, and gain in potential, because the height of the object has increased. Case 3. When the object is pulled downwards by applied force F. So, according to law of conservation of energy, work done by F and loss in potential, because the height of the object has decreased. So, work done by F and loss in potential, they both are initial energies, and they both will be distributed into two types of energies: change in kinetic and work done by friction. Case 4. This object uh, has been released on the line of greatest slope and there is no applied force. Therefore, no work done by applied force. And this is the height of the object from ground. So, loss in potential will be distributed into change in kinetic and work done by friction. This is EI and this is EF. Case 5. This particle is released with speed u, initial speed or velocity u, and air resistance is there. This is the air resistance. So according to EI and EF, loss in potential, this particle possesses potential energy. So loss in potential will be distributed into change in kinetic and work done by air resistance. What if there is no air resistance? Then all the potential energy will be converted into kinetic energy. Case 6. This particle is projected in the air, and this is the motion of this particle from A to G. So from A to G, and there is air resistance here and here. So from A to G motion, you can use this equation: loss in potential, change in kinetic, work done by air resistance. So this equation is for the motion from A to G. Braking method. In braking method, you have to break this situation. Break this situation like from A to B first and then B to G. So from A to B, at A, this particle has two initial energies: potential energy at A and loss in kinetic. So these two energies will be distributed into two types of energies: potential at B and work done by air resistance from A to B motion. Now this motion is from B to G. This is G. So according to EI and EF, this is air resistance. So loss in potential will be distributed into two types: kinetic at ground and work done by air resistance. So you can get work done from this equation and then work done from this equation. You just need to add both the work done to get the total work done. Case 7. This particle is projected vertically upwards. So So this particle has just one initial energy, loss in kinetic, and this will be distributed into two types of energies, gain in potential and work done by air resistance. If there is air resistance, then loss in kinetic will be distributed into two types. What if there is no air resistance? Then loss in kinetic will totally be distributed into gain in potential. This is resistance time height. Air resistance times height, work done by air resistance. And loss in kinetic means, use this formula, half m u square minus v square. Next case. This particle is released from this height h. At this point, at point B, at point A, this particle has this energy, mgh, potential energy at A. At B, it has this potential energy. So when this particle is released from point A or from this height, then at B, at this point, kinetic at B will be loss in potential. This particle is released from rest in this situation. The initial velocity is 0. So kinetic at B will be loss in potential, and loss in potential means potential at A minus potential at B. So if they ask find kinetic at B, then it would be potential at A minus potential at B. If they ask find kinetic at ground, then this will be potential at B, because all the potential will be converted into kinetic, provided there is no air resistance. Next, given that the plane is smooth and weight of particle B is greater than the weight of particle A, this situation is here. So when the system is released from rest, B will move in this direction and A will move in this direction. This is mentioned here when B moves downwards. So loss in potential will be this, potential of B minus potential of A. Height of A is this. And if they ask find kinetic, so gain in kinetic, this loss in potential will be transformed into gain in kinetic. So gain in kinetic is the loss in potential, provided the plane, this surface is smooth, slope is smooth. So loss in potential will be gain in kinetic, according to law of conservation of energy. Number 2, the speed of the particles. Once you get gain in kinetic, you can use this formula. Half mass of both the particles, square of velocity, and you have gain in kinetic. So by using gain in kinetic and this formula, you can get velocity of the particles. So gain in kinetic means kinetic of A plus kinetic of B. This means gain in kinetic. An important advice, always dress well. Best of luck. Allah Hafiz.